Repeatedly calling File.write is not idiomatic because it slows down your application. In this video, we'll learn Elixir-approved way to manage file access using the File and IO modules. Howdy, I'm Kevin, and in these videos, I explore AI tools to help us learn. I start with prompting Copilot to add documentation and provide a starting solution. We'll evaluate Copilot's code and explore alternate approaches. I'll include segments of a NotebookLM explainer video or quiz to introduce concepts. Here's how NotebookLM introduces the newsletter exercise.
Today, we're mastering idiomatic Elixir file handling with the newsletter exercise. Let's dive in. So what is it? It's all about managing stateful resources, like files, the right way. The key is Elixir's file module. It treats open files as their own separate processes.
Each call to File.write opens and closes the file, adding overhead for frequent writes. Using File.open keeps the file handle open, enabling you to perform multiple writes efficiently. IO.puts with the file's process ID is a more performant and idiomatic approach to IO in Elixir.
Okay, step one. Let's start with the first piece of the puzzle, reading data from a file. So, how do you grab all that data without a bunch of messy loops or error handling? Easy. We just use File.read/1. It slurps the whole file at once for us to process.
Step one is to read the file and get a list of the email addresses. So Copilot did a pretty good job with this one. We take the path that's passed into read emails. We pass that to File.read. We use the bang version here, so either that succeeds and we get the contents of the file, or it raises an error. So let's say it succeeds and we get the contents of the file. So now we have one giant string, which is all of the file contents. And then we pass that to string split on new lines, and we trim, meaning we get rid of any empty entries. And that will be our list of emails. Perfectly good answer. I think this is what the exercise is looking for. One side effect of this that isn't so great is that we read the entire file into memory and then split it. Another approach that's quite like this one is we take the path and we call File.stream. So this reads by default a line at a time. And so we're already just now getting one line at a time from the file. We're not reading the whole thing. It doesn't bring back the new line though, so we still need to trim off the new line, and then we can turn it into a list. So in both cases, we still get the full list. It's just in the second case, we didn't read the whole file into memory first. This exercise is simply exposing you to the File.read property, so that's the one we're going to go with.
Okay, we've got the emails. Now we need a reliable way to log them as they go out. All right, step two. This is where Elixir's whole process-oriented approach really starts to shine. You know, writing to a file inside a loop is super inefficient. There's a much better way. We use File.open/2. This gives us a single dedicated process just for handling our file. That PID we get back is our key. It's how we'll talk to the file. Let's see it in action.
Step two is to open a file for writing, the log file. And Copilot did okay here. So given a path, we need to open the file, like it did here, and we need to open it in write mode because we're going to be writing out what email addresses we successfully sent the newsletter to later. So we do want this bit. The File.open without the bang returns an OK and the process ID, or the file handle, if you will. And then we need to return that handle. We could have done better or differently simply by calling the bang version, and that either opens the file and returns the process ID, or it raises an error. This is the answer I think they were looking for. Is there a step I didn't fully explain or an angle I didn't consider? Your feedback makes a difference. Leave me a comment below.
Okay, step three. Time to use that file process to actually log a sent email. It's simple. We just pass that PID to the write IO function to write to our file.
Step three is to log a sent email. We're going to implement log sent email function. It should take the process ID that handles the file, the log file, and the email address will be a string. It should write that, followed by a new line. You may have found in the IO module the write function, and the write will put a string out to the file's process ID, but it doesn't append a new line. So you would have to append it yourself like this. Simpler is to use the puts function, which does automatically put a new line on the end. So you can say put to the log file process, the email address, and you'll automatically get the new line.
But hey, we can't just leave that file open. Proper cleanup is absolutely crucial. Step 4, closing the log file. This is what keeps our app robust and prevents resource leaks. And how do we do it? File.close/1. Just give it the PID, and it's done. Clean and simple.
Step 4 is to close the log file. Really not a lot to say here. You call File.close and you give it the process ID that's handling or managing the file. That's it. So, perfectly done. Did you know File.open is owned by a separate, isolated Erlang process? This is a massive feature. If your main email logic were to crash, the beam would automatically clean up that file handling process and free up the operating system resources, preventing leaks.
And step 5, the main event, the send_newsletter function that ties it all together. And here it is, the whole flow. See how each part is a small, distinct, and testable step?
Send newsletter brings it all together. The Copilot solution works, but I have some suggestions I think that would make it a little bit better, and I want to show you a couple of other patterns you might see out in the real world. So the first thing I would say here is, all right, so we read the emails. That's using the function we already did. That's fine. We're opening the file. For each email that we read, we're going to call the send function on that email. Now this is an argument function, so we need the dot syntax here. And if we get OK, we're going to log it. And if we get an error, we're just going to say OK, and then we're going to close the log. So I think this becomes a little bit clearer as soon as I put the open at the top, and then here now we're handling email in the middle. But I think the case statement adds to the confusion or the clutter here. So let's try this one. So we'll open the log file, and then we'll use pipes. We'll take the email path, we'll read them. Now we have a list of emails. We'll patch that into Enum.each. For each one, we're going to call the send function, and if it's okay, we're going to log it. We don't need an else clause because we didn't do anything with the else before anyway. So there's, I think, a better answer than what Copilot provided. You might also see some developers saying, well, I don't like all of this data inside of this Enum.each. And they would create a private function to do that work like this. So now we take the path, we read the emails, and for each one we call the function send to email. We give it the log file, the email address, and that function, and we put that if check down here in a separate function. And this looks nicer, particularly if send to email gets more involved than that. Another pattern you might see is to do the work here inside of Enum.each where we send it, but then we take the result and we pass the result to private functions that handle the return from the send function. So we pass it to handle result, and if it matches okay, then we log it. Otherwise, we do nothing. So of all of these, however, I think that this one will be my answer. We take the path, we pipe it to read the emails. For each email, we call the send function that they provided. If it's okay, we log it, and then we close the file.
So, what's the big takeaway? Thinking in processes. That's the key to great Elixir File I/O.
Log a like if you found this video helpful. Subscribe to receive the news when I publish a new video. Dive into the playlist to build your Elixir expertise one powerful function at a time. See you there.